Hi, babies. Hope you're doing great. I'm trying something new today. So instead of doing my whiteboard on the wall, I'm doing a screen recording. So let me move myself. I still want you to be able to see my face and laugh at me whenever you want to. I think that's kind of important. So, um, Thursday, Friday of this week, we are talking about scale copies or scale drawings. Way back to the beginning of the year, I don't know if you guys remember this because it was literally the first thing we did. You have two figures and you have to figure out what the missing part is, or you have to figure out if these are scaled copies, things like that. So let's just review two things that are really important with this. Um, oops. So with scale drawings, we've got two things that we need to remember. So you have the first thing, corresponding parts that we talked about. Those are parts that are in the same location. And so like X here is in the same spot as 13 here. If I were to go to this page, this line here is in the same spot here. Say I have a shape that up here, say I have a right triangle here, but then I have a right triangle upside down here. Well, this part and this part are not the same, but I've got to look, okay, this would be the bottom. It's just flipped upside down and flipped around. So those two are corresponding parts. Hope that makes sense. So then we have something called the scale factor, and that's the number that we multiply by to get the scale copy. So for this first example, the second figure is a scale copy of the first. Find the missing length. We have to figure out, what am I multiplying by to go from 15 to 30? Well, 2. So then whatever I do to that, I have to do the same thing here. Some number times 2 equals 13. Well, what is that? So it would not be 26. It would not be 2. 2 times 2 is 4. 2.4 times 2, no. But 7.5 times 2 is 13. So x would be 7.5 feet. Another way that we practiced this was you can create a proportion. So you can say original to the copy. So let's say this is the original, this is the copy. 15, I have to move that over. 15 over 30 equals something over 13, and cross multiply and divide, and you can do it that way. So there's two different ways that you can do these. For number 4, just practicing this, this is just, are these scale copies? So 6 times what gives you 4? Well, it's not times a whole number, but 6 times something gives you 4. If I were to work backwards, it would be 4 over 6, which would be 2/3. So if I do 6 times 2/3, I'd get 4. So let's do 3 times 2/3. 3 times 2 is 6 over 2, which would give me 3. Is that 1.5? No, it's not. Okay. Another way that you could do this one, let me use a different color just to not confuse you. Another way that you could do it, you could say original over the copy again. So we're going to say this is the original, this is the copy. We're going to say 6 over 4 and 3 over 1.5. Same corresponding parts go together in a ratio, okay? So 6 times 1.5 is 9, and 4 times 3 is 12. These are not the same number, so they are not scaled copies. Okay, so that would be a no there. All right. Whoops. Trying to make sure, my little stuff acts crazy sometimes. So for this one, it just wants to know the scale factor. So what am I multiplying by? Well, I'm just going to pick something easy. I'm going to pick this first section. So let's count the squares. So it's 4 units. And then the second one is just 1. So from 4 to 1, because from the first to the second, we can't just say 4. 4 times 4 is not 1, okay? So 4 times something is equal to 1. Remember, dividing by 4 gives me 1, right? So dividing by a number is the same as multiplying by the reciprocal of that number. So it would be 1/4, okay? All right. Oh, that thing's acting silly. Sorry. All right. So this one is a scale factor problem. Scale factor is 1.5. What is the new perimeter? So we're going to find the new dimensions and then we're going to find perimeter. So we're going to do 2 times 1.5 and we get 3. 7 times 1.5 and we should get 10.5, I think. Yeah. So I've got 3 inches here, 10.5 inches here. So now we're going to add 3 here, 10.5 here. I should get 27 inches, okay? And then the very last one, it wants to know x. So I know that these are corresponding parts. So I'm just going to figure out the ratio there. And then for this one, so I'm going to do that method of original to the copy. So I'm going to say that the original is the small triangle and then the copy is this big triangle, okay? So the original length here is 4.5, the copy is 13.5, and then the original here, the small one, is 3.2, and the big one is x. Okay, so before we do anything else, let's just think rationally here. If the original is smaller than the copy, obviously this x has to be bigger than 3.2, right? So if I take this away, I take 3 away, I take 3.2 away, the only realistic option is 9.6. That's one way to look at it. Then you can cross multiply and divide or figure out the unit rate, whatever. To me, process of elimination helps a lot sometimes. So anyway, so you guys have an activity on Desmos. It's about this silly little stick figure drawing. I thought it was really funny. So you guys will do that Wednesday, Thursday, and then on Friday you guys will have an assessment for just the stuff we've done this week just to see if you really got it or not. So I hope that this helps. I hope that you like maybe being able to see it on here better. I'm not sure. But anyway, just wanted to show you that. And I hope you have a great Wednesday, Thursday. And I shall see you soon. I love you.